Alright, how you doing everybody? We're back. We're going to check out a little bit more here on this setup. If you close down your scene file, open it up. Or if you downloaded the scene file from Ko-Fi, open that version up. If you did, you will notice there are different colors in here like I showed in the last video. You should always download these free lecture HIP files because if you dive in, you're going to notice something much different than what you saw on screen. There's typically a lot more notes in the HIP files that are saved online that you have access to. So if you haven't downloaded any of those files, I would suggest starting to do so. Before we get into the final section of this star lines setup, I just want to go over a couple things that I didn't add in the last lecture just because I was running out of time. Let's just go down here to the bottom of this chain. And like I said, it might look like all of our points are gone. There's none there. You know, these star points just grow on. But if we enable our points, we can see them now a little more clearly, and just go back, and you'll notice they actually still have a center point. It might be hard to see with this grid on, so let me disable that. Now they are much clearer. But you can see our source point, our center points are always there. Now, normally this wouldn't matter at all. It just depends. So if you did want to get those to go away, it's actually very simple. We can select any of these nodes here, but just let's use this one. This was our last node that we had used. And all you got to do is go here, and where it says curve U is greater than carve val, just put an equal sign. Now you'll notice nothing at all changes, but when we rewind, those source points are gone there in the beginning. They don't persist. And now the reason is, if you might recall, I explained this briefly, and I said if the curve U is greater than carve val, it will remove the point. Well, when carve val is 0 and curve U is 0, meaning our very beginning source points, curve U greater than 0, that would mean if you replace these attributes or these variables, that would mean 0 greater than 0. That is not true, so this line of code would never evaluate, or it would never be run. So all we got to do is put the equal sign, and now if curve U is 0, and we say is 0 greater than or equal to 0, then it is true, and therefore we will dive in here and run this code, and then all points will be deleted. That should make sense. It's very simple, actually. Another thing I want to show you is a way we could actually completely bypass using this measure and attribute promote. The main reason I showed you this setup here using the measure and attribute promote was it gave me a good reason to actually show the measure node. It's something that you may have never seen before. And we used that measure node so that we could get a unique value on each primitive. However, each primitive, each line already has a unique value, and that's the prim num itself, the attribute that's built into every primitive having a prim num, just like a point always has a pt num, it always has a number. Every primitive has a number associated with it. So we technically could just bypass this. Let's go over here, just alt and left drag this, and let's plug this in directly to our resample 2. Now we're cutting this out, and if we play, you'll notice now we lose that interesting growth variation. They all just grow on at the same, whereas if we look at this node, they have a variety of growth times here, or the lengths. Now, all you have to do is go up here and replace perimeter with primnum. Now, you're going to notice it changed it ever so slightly, but it still does the same thing of having each primitive grow at a slightly different rate. So technically, you could get around using these nodes, but I did want to show you how the measure node works. And this attribute promote, you maybe had never seen a node like that before. It's very useful to be able to change where a attribute lives, whether it be on a primitive, a point, a vertex, or detail level. That's going to come in handy later on. Another thing I just wanted to show you lastly here, let's actually disable this section of our code, just for example's sake. And I did mention a carve node. So if you hit tab, carve, drop it down, plug in, and let's look at it. You'll see we lose our core here or whatever, and you'll see how this removes our lines. Now you wouldn't want to use first U because that direction of erosion or carving it isn't the way we want it to grow. We want to use this second U. And now you'll see you can just go like this, just drag this slider. And if we back out, you'll see it does essentially what we actually set up manually, but it does it all at the exact same rate on every single one of these star groups. If you don't need to vary the way you are carving any geometry, you can just drop down one of these carve nodes. You can technically, though, use this data that we already created up here and plug it into the carve node. So instead of manually driving this slider, you can tell it attribute. Now, nothing happens, and you see we lose our animation. So let's give this thing our carve value here. So just type in carve val, and it's not going to like it. And this is a time when an error message is actually useful. It tells us, cannot find float primitive attribute carve val. So it is looking for a float primitive attribute. Why isn't this working? Well, middle click and you'll see that our carve val is a point attribute. So what can we do for that? Right here, our attribute promote. There's a reason why I showed you that. Just drop it down, plug it in. Original class is point. We want it to be a primitive. Go up here and tell it carve val, and look at that. Now you see it works as before. These little dots being shown, don't worry about those. That's just more of a visualization thing. If you drop down a null, now we can see that they aren't actually there. That's just something you see when you're on your carve node. But you can see you get the exact same thing. Now, is there really any reason to use a carve node when we've already done all of this setup in a wrangle? No. Only thing you're saving is these two little lines of code, and you should just do it all in the wrangle rather than set up all of this randomness and then drop down a carve value. I would always recommend just doing it all in your attribute wrangle. I just want to show you the versatility of Houdini and the fact that I say this all the time. There is always more than one way to do anything in Houdini, and here's just another perfect example. So now that we've looked at these few little things, let's actually get this working over here on our spherical surface. Remember, it's always more interesting to work on a three-dimensional surface than a flat plane. Currently, it does nothing. We haven't added any of our cool randomization and growth stuff over here. So let's do that now. Let's check this out. So let's copy what we need. There's no need to redo this stuff. Let's grab our connectivity node, our resample, our measure, our attribute promote, and our attribute wrangle. Copy it, paste it, plug it into this output of this wrangle. And you'll see we get our exact same thing as expected. Now, if you want, you can disable these and change this to, the prim num, but I'm just going to leave it here as default as we did it originally. Just know that there's other ways of doing it. And now let's drop down. Let's drop down another resample and plug in and disable this maximum segment length and just go down here and re-enable curve view attribute. Now we've already created a curve view. As you can see, if we middle click here, we have curve view, but that curve view was created before we did all of this erosion or this carving. So now we're going to recalculate curve view so that it's always going to be giving us a 0 to 1 value down the length of one of these primitive lines, no matter how long it is. Before, when we first calculated it, it was when it was at its full length. So it would be 0, let's zoom in and say it would have been 0 to 1. And now it would have been 0 and 1 would be out here. So this would only be, say, 0 to like 0.2. That's not accurate. I'm just using it as an example. We want to recalculate it so that it's always going to be 0 to 1, no matter if the line's just born and it's 0 to 1, or all the way at full growth, it'll be 0 to 1 by recalculating our curve view after our carving, and you'll see why. Let's drop down another wrangle. And now we can do something like at CD is equal to curve view. And you'll see now they fade actually. And why is that? It should be very clear because our value starts at 0, goes to 1. So now we see it's 0 here and fades on slowly up to a value of 1. And you'll see it does that the entire time. If we disable this resample, you'll see it gives us wildly different results. Like I was saying, it will only be 0 to 1. And when we are in a middle range here, it's 0 to say like 0.2. But we don't want that. We want it to recalculate it after our carving. But now we're going to use this to taper the ends of these because we're going to give them thickness. We're going to have actual geometry. So we want to invert this. And it's very simple to invert any value that goes between a 0 to 1 range. If we go up here, just type 1 minus. Now click off of it, and you'll see it flopped the result. Now it's white here, and it's black out at the end. It goes from now 1 to 0. Now I'll try to just describe why this occurs. It should be fairly obvious. Let's say before, when this value was 0 here and 1 out here. If we do a 1 minus curve view, so now here, where the curve view used to be 0, we're saying 1 minus 0. What is 1 minus 0? Well, it's a value of 1. So now it's going to be completely white. At the end here, where this value used to be 1, what is 1 minus 1? 1 minus 1 equals 0. So now it's going to flop it, and this is going to be the black value of 0. It just does that down the whole range. That should make total sense. And now we're going to be able to use this to taper our geometry that we create. But before we create geometry, let's make this more interesting. It's always good to try to make your setups more interesting. Although this is very cool already, let's try to have some unique shapes and some squiggly lines here instead of these straight lines. We have tons of resolution that we can noise these up. So just hit tab and drop down a VOP. An attribute VOP will be fine. We can dive in. And now we're going to do a turbulent noise. Plug the P value into pose. Change this to 3D, and let's go with something like zero-centered Perlin noise. Drop down an add node. Plug P into the first input and the output of the noise into the second. And then we can plug this sum into P. Now you'll see they displaced quite a bit, and it's no longer nice and spherical, but that's fine. Let's adjust these values a little bit. Let's go a higher frequency, something like 13. Roughness, you can reduce the roughness, maybe reduce the turbulence, maybe reduce the amplitude. Okay, so that's kind of cool. Now, preemptively, we know we're going to want to make these move, and we know we can't animate when we're in here at this vex level here, so we got to promote this offset. Just click this little sprocket, promote parameter. Now that gives us access up here to that parameter, and you can see we can do something like this. Let's automate it by putting like $F times 0.05, and now let's hit play. And you can see we get this really cool, almost alien-like motion or underwater movement. But if we hit tab and type merge, and we want to bring our sphere back in here, let me also tell you, if you don't know this, you can hit the shift key and you can click any line that's going into a node and get a duplicate of that line. Like, see how that works? Just hold down your shift key and left drag. Instead of having to go all the way up here, click the output of the normal and then scroll back down and plug it in. A hotkey way of doing that is shift and left drag to get the line to come out, in case you didn't know that. So now we can see our little creatures, or whatever these are no longer nice and conformed to our surface. Maybe that's fine for your case, but we don't want that. We want to actually have them stuck to the surface and still have that nice noise running through them. So very, very simple method of fixing that. Let's just find where we had our min pose. Let's see where we went. There we go. You could just do Control C, Control V, and change that first input to the output of this attribute VOP. So we want the output of this node going in here, and the second input is going to be linked to our sphere, and you can see they already sucked back down to that surface. You can toggle it on and off, and see we still retain a lot of that noise. And now swap these plug in here, so now you can see we get this nice cool movement and animation, but it is stuck right on the surface of the sphere. So that's cool. But let's make it even more interesting. Let's drop down. Let's think here. Let's do poly wire. And now you don't want to plug it into this output because this has both our sphere and our little squiggly line star geometry. We only want to work on our squiggly line stars. And by default, this is horrible. This is huge. So what can we do? Well, we want to use this CD value so that they'll have their full width here at the origin, and it's going to nicely ramp down to a 0, so we'll get a nice tip in a sense. So you can just type at CD. But that's going to be huge still because we're giving it a value of 1, where the CD value is 1. So multiply this by something very small. Let's try 0.0025. We might have to change that, but let's not put the little semicolon there. I felt like I was writing a line of Vex for a moment. Now you can see we get a much, much nicer look. And if we hit W key to go into wireframe, you can see you have actual legitimate geometry now. Now it's going to get a little slowed down here because there's quite a bit of faces here. You could technically resample your lines if you didn't want this many segments, you know, or you can do some changes in the polywire here, but we're just going to leave it as is for now. And let's just drop down a color node and give these a nice bright color like red so we can totally see them. And now swap out. And look at the result here. And we could always drop, let's say, a normals node. You could do it anywhere you want just for this example. See if it changes anything here. Yeah, you can see the surface, how it calculates its shading a little differently. Sometimes you need to create a normals node at the end. You could actually do it up here too, but this is going to do it on both the sphere geometry and our little squiggly lines. So I'm going to run a play blast out so we can see this in real time, because if we rewind and hit play, you can see it starts to get a little slowed down here. So I'm going to go like this, and let's just say 150 frames. And I am going to pick this back up once this is done. All right, that's done. Let's check it out in motion here. You can see that's pretty cool. A lot more unique and interesting rather than just having straight lines. You can see there's a little pop going there basically in the brightness of that sphere. Once these things start to come on, we can fix that probably pretty simple. Let's see what's going on here. Where did it happen? Around 10? 12? Let's see here. Let's turn off these do vertex textures. It's really just doing something in the display here, but because it's distracting, we can turn that off. And now you see it doesn't do it. In reality, if you wanted there to be textures on these squiggly lines here, once you made that geometry, you'd probably want to keep that on. But for this example, it doesn't matter. We're not going to be doing any type of shading or lighting. Let's just go back to this result here and check it out. So you can see it's very simple to do very cool things, and you could use this for a variety of different effect setups. I just want to show you the possibilities of using Vex and Wrangles. It's very interesting to be able to do this organic growth that's completely randomized on a per object basis, and it really didn't take much effort. If you look up here, it's not much. There's just a few lines of code, and you can drive all of these little creatures, or whatever you want to call them, So that's all we're going to be looking at in these star lines examples. I'm still going to do more Vex and Wrangle related lectures, but it's been now, I think, 3 episodes of these lectures that have all focused on this star line setup, just because there was quite a bit to show you. And these techniques can be applied to so many different things. Don't think it only applies to creating these little splotches. This alone right here, doing this carve val and creating these start frames that are driven by these random values based on a class, is the basis of so many rigs I can't even begin to explain. You'll see what I mean, and the more you use Houdini and the more uses you will find for these little ideas here. So I hope you like this video, and I'm gonna end this one here. As always, you can check out the scene file if you want to download this over on my Ko-Fi page. Here's the link here. It'll also be down in the text of this video in the description. As always, these are the free level courses. Feel free to leave a tip or donation to try to help keep these free. Eventually there is going to be subscription level courses that will be longer and more in-depth and more advanced topics. That's going to be coming in the near future. Those will only be available to be watched through Ko-Fi because you'll have to subscribe. And as usual, I gotta tell you to hit that like and subscribe. That's the only way this channel will get, I guess, promotions or be seen. You gotta keep that algorithm happy to make sure this channel stays relevant. With that being said, we are done here, and I will see you in the next one.